So in preparing this webinar on SRU cost savings, a big precursor to that was a question that we constantly get from our clients, which is, how do I get back the money that I spend on your services? And I have to say, as a person who's a subject matter expert on SRUs, I'm kind of a bit dumbfounded by this question, because just like your car, you need to do proper maintenance on it in order to gain the proper life out of the vehicle, out of your investment. Just like the SRU, an SRU, multi-million dollar piece of equipment, the process, the equipment, everything that's running into it, it just makes sense that you would put in the required maintenance in order to verify that the unit's running properly, in order to maximize the value that you're getting out of it throughout its life cycle. And so in order to answer that question, we came up with this webinar. And I know a lot of you would probably be very excited and interested in knowing about some certain payback period examples. And we will definitely get into that today. But in order, or before we can talk about those examples, it's good to first outline all of the associated costs with the SRU. What we're doing is we need to look at all the externalities. It's quite possible that as a process engineer, you're looking at the overall recovery efficiency, making sure that you don't have any emission violations and such like that. But maintenance department might be looking at, well, we need to replace certain equipment. What's our budget? Let's reduce our costs in that way. Otherwise, there's environmental. An environmental group might be saying, well, okay, well, how do we reduce our CO2 emissions? Because we are paying a carbon tax on that. And then overall, the plant manager saying, or the operating company says, okay, well, we're supposed to get 25 years, 50 years out of this SRU, but we're having so many problems with it. Everything's shutting down that it looks like maybe we will only be able to get 40 years, 30 years out of it. So there's different stakeholders all dealing with the SRU. And so with this presentation today, what we're going to do is talk about all of those associated costs, which all those externalities. Then we'll go ahead and put some methods on how we can reduce those costs. And then we'll give some examples. But first, before going through that, we definitely need to do some introductions. So I'll introduce SRE, Sulfur Recovery Engineering, and myself, and then we'll go into everything else. With respect to SRE, we've been around since 1998. We've helped refineries, gas plants, engineering companies here in Calgary, Alberta, Canada, worldwide, in achieving their optimal performance of their sulfur recovery units. We started off in the SRU. Since 1998, we've grown. Now we cover multiple units in terms of doing test work for them, our bread and butter. And we've grown our business to provide consulting services in terms of SRU design, engineering, and commissioning of the units. And we also provide lifelong SRU servicing, which includes performance evaluations, troubleshooting, shutdown, and startup support. Really, we're focused on the reliability, performance, protection of the unit. We want to make sure that you're getting the most that you can out of it, out of the SRU. Now, all of these services, I like to put them into three different categories. At SRE, we have our testing capabilities, we have our simulation capabilities, and we have our learning capabilities. So under testing, some of the things that we do, on-site sampling and analysis, provide results right away at the end of the day. Don't have to wait 2 weeks for them. Commissioning, startup, shutdown assistance for sulfur recovery units and also acid gas recovery units. Also, we have some testing products that we can sell too, should you want to do your own test work in-house. Under our simulation products, we do a lot of work with VMG Sim. We provide tuned models that allow you to simulate your plant exactly how it is. We do dynamic modeling, optimization, and design consultations. And then with all of our experience that we've gained since 1998, we're trying to give back. We have learning services in order to train your engineers, your operators. We also do training for EPC companies. What we do is we tailor those courses to exactly your objectives, to your needs. And should you want, we also have simulation training with VMG Sim. A little bit about myself. I'm the principal process engineer here and partner with Sulfur Recovery Engineering. Over the past 9 years, I've completed over 75 projects. I want to say that number might be close to 100 different SRU projects at this point. I would have to say that my most memorable experience is being stuck in Rainbow Lake, Alberta. For those of you who know where that remote part of Alberta is located, I was stuck there for 6 weeks in 2009 doing some work for a client up there, and that was definitely interesting. And if you want to know more, definitely ask me about it. All right, enough with introductions. Let's go to associated costs. And like I said at the beginning, what we need to do is take into account all the externalities. We're in some way, shape, or form paying for a lot of the items that are in the SRU. Maybe your specific role, you don't get to see those costs, but in some way, shape, or form, there are costs associated. And when we're talking about payback periods, we need to identify all those externalities. So when I looked at it and I was thinking about all of this, I kind of summarized everything into 3 different categories. We've got our operating costs, $1. We have our maintenance costs, $2, a little bit more expensive. And then we have emergency costs. This is where things really goes bad. And I put $3 here, cost a lot more to get those things done. And when we look at some of the examples at the end of this webinar, you'll see where these numbers kind of fall into place. Now, for all the associated costs, I've listed them out here 1 through 9, and we'll go through each one of them. So the first one here is fuel gas. And fuel gas is used in the incinerator at the thermal oxidizer when we have to reduce those remaining sulfur-bearing compounds into SO2 and disperse them via the stack. We also use fuel gas in the main burner if we're co-firing with lower quality acid gas. And we could also be using it in the reduced gas generator to provide that hydrogen necessary for Scott units for the hydrogenation reactor. Now, I do realize that fuel gas might be a bit misleading. We have fuel gas, but we also have natural gas. And we should differentiate between refinery fuel gas that is, say, mostly methane versus refinery fuel gas that might be full of, say, hydrogen, 30%. And it's important to note, and I'll put this in here, that these numbers that we're presenting are a somewhat general numbers, a generality in this way, because a lot of these things will vary from region to region and jurisdiction to jurisdiction. For example, here in Alberta, there is a price for emitting carbon per ton, but other facilities may be in a jurisdiction where there's a cap and trade, and so providing that number might be slightly different, or they might be in a jurisdiction where there is no price for carbon. Exactly the same thing, you might be in a situation where your refinery utilizes refinery fuel gas, at which there might be an abundance of it, and to the operator it might be a small contributor in terms of dollars amount, but nonetheless, if you're looking at all the externalities, we should put a dollar figure to it. Going on to number 2 is hydrogen, and again, we're talking about, in this case, not using fuel gas to generate the hydrogen, but using hydrogen that's created on site in order to use that for the hydrogenation reactor and Scott units, or TGTUs. Now, with using your own hydrogen, there is also a downside to that. Some of our clients use hydrogen, but that hydrogen contains contaminants, heavy hydrocarbons, or catalyst poisons, BTEX components. Now, it's important that you realize that, yes, you might be saving on your hydrogen costs because it's already readily available, but you're also reducing your catalyst lifespan because the hydrogen has catalyst poisoning compounds in them. So again, it's important to take into account all the externalities. Yes, you're not paying for hydrogen, but you might be losing somewhere else. Finally, on operating, we've got CO2. Like I said, most jurisdictions now have a price per carbon that's being emitted. Going under maintenance costs, obviously, in the SRU, we have catalysts. Normally, you have 4 to 6 years of catalyst life. You'll be able to get that with proper maintenance. A regular alumina, $35 per cubic feet. Titania, in order to get that really good hydrolysis numbers of COS and CS2, you'll be paying more, $300 per cubic feet. And the Como catalyst, this is what's in our hydrogenation reactor of the Scott unit. It's a little bit less expensive than Titania, but still pretty expensive at $250 cubic foot. Again, these are general numbers just to give you an idea of what we're talking about, the relative costs that are associated. Now, obviously, it varies operator to operator. There's some clients of ours who have been running with alumina for 10 years now, continue to get good recovery efficiencies through them. Likewise, there's other operators who are having difficulty with their upstream units. They constantly have upsets, and if they get a year, 2 years, they're happy with that. So it definitely varies, but there is a cost associated with replacing that catalyst. And likewise, when we talk about payback periods, there's potential savings for extra years of life that we can get out of that catalyst. Next one in terms of maintenance is condenser tube sheet failures. There's a cost associated with that. Say we don't maintain the proper thermal gradients during our startups and shutdowns, we may stress those welds. Cost of that, at least 5 figures. If we were to damage our refractory, either in the reaction furnace or in the catalytic converters due to a runaway fire, is that going to cost $50,000? Some people, it might cost $5 million in order to get all of that done. And another thing is plugged rundown lines. It's true that a plugged rundown line can be rotted out by the operator on site during that day shift, but there are some cases where the plug rundown line has to be unplugged by an operator who's working overtime, or it's outside of the operator's scope of work and you have to bring in a third party in order to unplug those rundown lines. So something simple as that also carries a cost. And when we're looking to reducing costs, we must look at all the externalities, all the costs that are associated. Under maintenance, I've included performance evaluations that SRE conducts. Just like how you go get your engine tuned up, you go for that 50-point check to make sure that everything's running properly. Well, SRE's performance evaluation does just that. We verify the equipment, verify the process, how do we optimize it, what recommendations are available in order for you to gain a reliable unit and improve the life of your SRU. And we'll go into a little bit more details of that. And we recommend doing that on an annual basis. And for a typical Klaus unit, 3-stage with a Scott unit, TGTU, that will be in the ballpark of $35,000. Finally, emergency costs. Here's where things go wrong. You're in a situation where now you're emitting SO2 into the atmosphere. You've gone beyond your regulatory requirements. There's a fine that's going to be associated with that your regulator is going to impose on you. Here in Alberta, recently, an operating company was fined for H2S release of $500,000. Not only is there a fine for violating, there might be a fine for violating on a daily basis. Say your SO2 number has to also include not only what's coming out of your stack, but also SO2 numbers from your flare. As such, you might have a daily violation cost as well. And now, especially with the Paris Accord, things are going to get more strict. There's going to be violations, if not already, for methane and CO2. Number 8, troubleshooting an offline SRU. This is an extension of the maintenance portion of equipment failure from the previous slide. But now we're going further. What is the cost of having a third party come in and evaluate and troubleshoot the problem that led to this emissions violation, the problem that led to the equipment failure? This is beyond just replacing the equipment. This is to identify what is going on, identify what is the actual problem. And you could pay a company like SRE upwards of $100,000 in order to troubleshoot the unit. Let alone troubleshooting the unit, if the SRU is the lifeblood of the refinery or the gas plant, then you'll have production losses because that SRU is not operating. And I put here a minimum of $100,000 per day, but I think that's very conservative. For some of our clients, that could be upwards of $1 million per day in production losses because the SRU is down. Last thing, in terms of emergency costs, the EPA, your local regulator, might force a consent decree or third-party verification, in which point you'll need to have a company like SRE conduct performance evaluations on a quarterly basis or monthly basis, at which point that same $35,000 that we were talking about on an annual basis in the previous slide is now a per quarter cost that you'll need to do. So I hope that outlines, and you all agree that these are the costs associated with operating your SRU, and that can happen. So what can we do in order to save money? What can we do to prevent having to spend all of that in replacing costs and in avoiding those fines? So when I was thinking of that up, I came down to 4 different ways. And it seems the best way to present it is that they're all layered on top of each other. On top of this pyramid is to improve your upstream units. After that, obviously, reduce your fuel gas consumption. Third one, you don't want to get away from your regulatory requirements in terms of emissions, so you want to increase your SRU performance. But the foundation of all of that is SRE services, and I'll explain that a little bit further. So how does improving your upstream unit help you out? How is that going to save you any money? Well, if you've tuned into our other webinars, especially the last one on troubleshooting last month, you'll know that the SRU is only as good and can only operate as well based on the feed that it's given, what's coming to it. So if you were to increase the quality of your acid gas, you'll end up getting a higher recovery efficiency. And that's what this chart to the right represents. As you go to the right on the x-axis and increase your H2S concentration in your acid gas, your net recovery efficiency increases based on a 2-stage or a 3-stage modified Klaus process. Likewise, if you were to have a lower quality acid gas, you'll have a lower recovery efficiency. And as well, if you're not having enough H2S, that means you're adding in CO2 into your acid gas, and therefore your throughput to the SRU also decreases. Improving the feed stream can be done in a number of ways. For one, you could reduce the amount of hydrocarbons, reduce the amount of BTEX components, reduce the amount of ammonia in your amine acid gas, and reduce that CO2 number. Invariably, what you're doing is you're trying to increase that H2S quality and increase the quality of your acid gas stream. Increasing your acid gas quality increases your net recovery efficiency, which decreases the likelihood that you'll have those emission violations and thus decreasing your costs. Next method of cost savings, reducing your fuel gas consumption. Frequently, our clients, when we ask them, okay, well, are you looking at the cost of your fuel gas? And nobody seems to be saying a definite yes. They'll say, yeah, somebody's looking at it. Yes, that's this department's responsibility. Or they'll just say, no, we're just worried about our SO2 emissions. But we're using the fuel gas in the incinerator. we're using it in the main burner, we're using it in the RGG. So even if the costs of the fuel gas itself might be minimal, even a small reduction over a 1 year, 5 year, or even the lifetime of the SRU can result in substantial savings. And we'll look at an example of that in the payback period examples in the next section. Third is improve your SRU performance. So in order to improve your SRU performance, what costs are you going to reduce there? Well, you'll increase your catalyst lifespan, and as such, you'll be saving money, because instead of getting 4 years, you might get 5, you might get 6. So that's extra money that's coming into your pocket that's not accounted for. In improving your SRU performance, you're ensuring that your equipment stays reliable. You're identifying, is there any process equipment that's not performing as well as it should? At the same time, improving your SRU performance means that you're increasing your recovery efficiency, which means that you're taking all the precautions necessary in order to ensure that you're not violating those emissions and you won't have those hefty fines. And last, having regular maintenance done on your SRU in terms of a performance evaluation means that you have the data necessary to spot problems early. You could go now into a proactive approach on your SRU versus a reactive approach. Now you have every 6 months the data necessary to identify, oh, my outlet concentration or compositional analysis from my main burner has changed. Why? Versus when you're troubleshooting, you'll see the compositional analysis for the first time and ask yourself, is this normal? Proactive versus reactive. And the bottom line of improving the SRU performance is to reduce the likelihood of those costly emergency shutdowns and the loss of production. That's where that big $3 sign emergency ticket, emergency costs come in. Finally, SRE services. Now, I say that SRE services is the foundation of the previous 3 cost-saving methodologies because you need at least one item before you can get started on any of the three projects. And that item is reliable data. When you're dealing with sampling from the sulfur plant, you're dealing with 1, high H2S concentrations, 2, you're dealing with sulfur bearing compounds, and 3, these compounds are highly reactive. So it's important that you retain a company that has personnel trained in dealing with high H2S. Also to retain a company who understands that these compounds are highly reactive and as such have the right sampling methodologies and testing methodologies such that the data, the analytical data of what's happening in the interstage units is reliable and repeatable. Without proper data, you can't make the right recommendation on reducing your fuel gas, improving your catalyst activity, ensuring proper destruction within your main burner. So the best way to reduce costs all around is through SRE's performance evaluation. Here, we're ensuring that each equipment is operating in the best manner. We're trying to provide recommendations to increase your catalyst lifespan. And we're looking at all areas in order to increase and improve your overall SRU performance. So we definitely recommend the performance evaluation. Our next service is startup and shutdown support. Here, we're dealing with the SRU running in a dynamic state. We're no longer running in steady state, we're going through dynamic state. So there's a few things to consider. One is the proper thermal gradients within your reaction furnace and your heat exchangers, the waste heat boiler and the condensers. You want to ensure that you're not causing any stress to those welds, causing any stress to the refractory. Further, with stoichiometric burn, you want to make sure that you're not destroying your catalyst, you're not sooting up the beds. Overall, at the same time, when you retain SRE for startup and shutdown support, you're making sure that you're not going to be paying for extra emission violations while you're going through the shutdown of a unit, ensuring that you're not having runaway sulfur fires, which will result in emission violations. You know, the regulatory body doesn't really look at if you're operating at steady state or if you're shutting down the unit for maintenance. They're just looking on a quarterly basis. Are you above or are you below your SO2 limits? Finally, by retaining SRE, you can remove the need for a nitrogen chuck. Now, I put a value here of $50,000, but that really depends on the size of your SRU. Do you need one truck? Do you need two trucks in order to cool that down? $50,000, $100,000 to get nitrogen at a gas plant where nitrogen is not readily available. Some refineries, nitrogen might be readily available, but retaining SRE in order to conduct the shutdown of a unit saves you that money. O&M support design review. SRE, with our years of experience, we can make sure that the equipment is laid out ahead of time. We have one client that, they're telling me they had to hire in 2 cranes for their shutdown because they had to remove a condenser. But above the condenser was the converters, and above the converters was the reheaters. So in order to fix one condenser, they had to move 2 other pieces of perfectly good equipment. That's one design thought that wasn't considered during the equipment layout. Could have saved them a lot of money downstream. So really, operations and maintenance, conducting the work ahead of time is beneficial and saves you costs down the road. Further, we have a lot of clients who tell us, well, yeah, we have to increase our recovery efficiency, so we're just going to throw in a Scott unit. Yes, that is the norm. Everybody is moving towards this absorption TGTU process and as a tail gas treatment. But is it the right choice? Is it the lowest CapEx, lowest OpEx? With SRE's experience and breadth of experience with different technologies, we are able to recommend the better solution with regards to meeting new regulatory environment regulations. Incinerator optimization. We want to ensure that we're only using the fuel gas amount that's necessary to oxidize those sulfur-bearing compounds, while still maintaining proper SO2 plume dispersion and ensuring that we're meeting the destruction requirements by the regulatory body. At the end of the day, what we want to do is reduce the amount of CO2 that we're emitting into the atmosphere and thus reducing the costs on carbon. We have here the SRU and TGTU and amine optimization, improving your overall recovery efficiency of the unit helps you in maintaining the reliability of the unit, as well as reduce the likelihood of paying fines for emission violations. Again, with the optimization, we can identify areas that we can reduce fuel gas consumption. We can identify areas where we could increase our catalyst lifespan. And like I said, the reduction of emissions. Finally, this SRE service individual gas analysis is good for those troubleshooting jobs. Let's troubleshoot exactly what's happening in the unit. Let's grab samples from a specific location and quickly do the analysis of those within 5 minutes and figure out what's going on. It's important to note that really all we need is 2 samples, the acid gas coming in and the tail gas going out, in order to determine the recovery efficiency, the overall recovery efficiency of the unit. And so getting individual gas analyses done definitely might be the best way to go for certain problems. So this slide, this table outlines those SRE services, A through F, and how they relate to the costs that we identified at the beginning, 1 through 9. So like I was mentioning, the performance evaluation covers all of those costs that we see: fuel gas, hydrogen, CO2, our catalyst costs, our equipment costs, performance evaluation emissions. Whereas the individual gas is more tailored towards the troubleshooting, or if you had to do a performance evaluation or consent decree at proving your overall recovery efficiency on a regular basis. And now to the section everybody is waiting for, payback period examples. This first one has to do with the annual spend on SRE services. So what we have is, like I said at the beginning, SRE recommends that you do an annual performance evaluation, annual meaning on a yearly basis. And what this chart has is represents 3 clients of ours, client A, B, and C, over a period of 2007, 2008, 2009, and 2010. And how much those clients spent on SRE services. It's important to note that prior to 2007, clients B and C retained us on an annual basis to conduct their performance evaluations. As well, they also retained us when they were doing their turnarounds for shutdown and startup support. With the performance evaluations, we provided recommendations to them on how to improve the unit, increase the reliability of the unit, and they followed through with those recommendations and implemented them. Client A, however, only retained us sporadically whenever there was an issue prior to 2007. And as you can see, in 2009, their problems increased. They were having major emission violations, equipment failures, etc., resulting in them retaining us for over $600,000 worth of work. Now, what this chart doesn't show you is the related costs. This is only the costs associated with them hiring SRE in order to troubleshoot and provide consent decree information, etc. Other costs that are associated with this problem are catalyst costs. They had to replace their catalysts. They had to replace equipment. And what other third-party troubleshooting with respect to upstream units or respect to specifics within the SRU other than SRE that they had to spend. So my question to you would be, does it make sense? Like your car, you bring it in for your oil change and your 20-point, 50-point inspection on a regular basis to make sure everything's good and you follow the recommendations. And what happens otherwise? Otherwise, your car shuts down on the highway. Well, just like the sulfur plant, this client A, did not spend the money or did not follow recommendations or have even recommendations made available to them. And as such, things spiraled out of control beyond the point of no return. And, you know, the sulfur plant at a lot of facilities is the lifeblood. Without it, production ceases. And so in 2009, they had to spend the money that's necessary. Mind you, this money is not available in anybody's budget, but when it comes to restarting production, the money comes from somewhere. And they had to spend the money in order to get things going. Next example here is increased catalyst lifespan. So we have another client who replaced catalyst every 6 months. Now, this was prior to SRE being retained to help them out. They had operational issues, and it was one of those operating decisions that every 6 months we'll replace our catalyst. Mind you, this is a small SRU. Catalyst replacement costs were approximately $30,000, so about $60,000 per year. Cost of keeping up production and making sure that the SRU is running? Sure, no problem. We'll spend $60K a year, replace the catalyst, no worry, no headache, nothing. SRE was then retained to conduct some other work in the sulfur plant, but we identified while on site that they were having incomplete combustion of catalyst poison compounds within the reaction furnace, within the main burner. So while on site, we recommended to them that, hey, let's spend an extra day of testing. What we'll do is we'll start co-firing with fuel gas in order to ensure that you're getting complete destruction of those catalyst poisons. So now, instead of replacing their catalyst every 6 months, they're replacing their catalyst every 1 to 2 years. Yes, that's true that they're not doing the normal 4 to 6 years. They're still having operational issues with upstream units and some other issues that we're helping them out on. But right now, just within that 1 day of testing, they're saving $60,000, just like that. The payback time for this project is less than a month. I actually think it's probably a couple of days. So 1 more day of testing in order to ensure that you're not replacing your catalyst every 6 months. You're getting 1 year, you're getting 2 years out of it. Definitely getting $60,000 into your pocket is, in these days, it's definitely a favorable situation to be in. Number 3, incinerator optimization. Here we're talking about fuel gas savings. So how much can you save on fuel gas? Well, with this client, an annual savings of $438,000. We arrived on site to do incinerator optimization. We determined that the stack temperature could be reduced while still meeting environmental regulations. It was so much so that we reduced the fuel gas from 45 to 20 E3M3 per day. So this graph shows you the blue line, the current spending that they would do per month in hundreds of thousands of dollars on fuel gas in their incinerator. And the red line is the cumulative savings at 20 E3M3 per day. Not even 2 months went by and they saved the amount of money that they were already spending. On an annual basis, they're saving $440,000. It's a lot of money. And that's why I said even a small reduction in fuel gas consumption anywhere in the SRU can result to substantial savings as long as you're putting a dollar figure to that. And the final example, and I had to, when I was creating this presentation, I had to put in exactly what our clients keep on telling me. I have a Scott unit. I don't need any testing. My Scott unit takes care of everything that's happening upstream. Doesn't matter if my Klaus unit is not operating 100%. It's not getting the optimal recovery efficiency. My Scott unit takes care of it. My TG2U takes care of it. Thank you very much for your phone call. Well, let's look at what happens. Let's look at what happens when you improve your Klaus recovery efficiency from 96% to 97.5% for 100 tons per day SRU, typical. And it's possible to get 97.5 out of your 3-stage Klaus because if you optimize it well. When we do that, what happens, that increase of 1.5% in recovery efficiency results in a $69,000 savings in fuel gas consumption in your RGG. What we need to do, what we're doing here is we're looking at how much fuel gas do you need to use in order to generate the hydrogen required to hydrolyze remaining sulfur-bearing compounds back to H2S in the Como bed, in the hydrogenation reactor. Further, when you look at it, we're reducing the loading on that hydrogenation reactor. We're making sure that the Klaus unit is doing most of the work and reducing the loading on that hydrogenation reactor. That means that the catalyst is going to be lasting longer. So if we break it down, fuel gas, what we would spend at 96%, $184,000. What we would spend if we're at 97.5% in our Klaus unit, that reduces down to $115,000. Now the cost of our Como catalyst, let's say for example for this 100 tons per day unit, say for example it's $115,000, and it'll get, for example, a 5-year lifespan. Each extra year that we can get that catalyst to live longer that's pretty much $23,000 that we're keeping in our pocket. So in total, we're saving $92,000. The payback for this type of project would be 5 months. Definitely some food for thought for those who think that my Scott unit is doing everything. There's no way I don't need to do any improvements. Well, when you do the numbers and you look at all the externalities, there is potential for a lot of savings just by improving your Klaus unit. And this is where it comes full circle, right? Where the catalyst to get this webinar done was the question, where's the payback by having your service? And that's why I was dumbfounded, because as you look through these examples, the payback is not in a matter of years or decades. The payback time in these examples are a matter of months, if not days. So to wrap up, some final thoughts that I want to part with you guys. What to remember about SRE. One is we've always been and will always be on-site problem solvers. We can identify what's going on with the unit, fix it, ensure that the unit's running reliably, provide you with on-site analysis and recommendations. Number two is we're here to answer all of your questions. We get emails all the time with respect to clients having issues. They send us, or we will request DCS screenshots. We'll reply to any of your questions without us having to come on site if possible. And third thing I want to part with you guys, how much money can we save you? These 4 examples were potential costs. 3 of them were examples, and 1 was a potential cost savings. So definitely with your unit, how much money can we save you? So I'd like to thank you for your time. We're gonna open up the Q&A. Got a question here that came through email asking me, what about Steam? That's definitely a good question. We're talking about all the externalities, and I didn't mention one of the big utilities within the sulfur plant, steam. Well, my assumption there was that the steam that's produced in the sulfur recovery unit is sufficient for its requirements. So the steam that's being produced in the waste heat boiler is sufficient for rundown lines, et cetera, heating that's necessary. Further, there's also some clients who have high pressures, a significant amount of high pressure steam that's produced, and that becomes actual valuable commodity because now that high pressure steam can be utilized in other areas of the plant. We're currently talking with a current client that is able to utilize that high pressure steam in order to produce some electricity, which is a very interesting concept. And if anybody's interested in learning about that, they can always contact me. So we have one here on amine circulation. We feel that our vendor overprescribes, more costs with that, more energy to regenerate. Any comments from your performance testing? Great question. I believe this person's main point here is to do with the circulation rate of the amine unit and what we think about that. And I'll go ahead and talk briefly about that. So circulation rate. So if we're talking about amine circulation, more cost, more energy. So what we've seen is a lot of our clients, when we take our acid gas samples, we noticed a significant amount of hydrocarbons. Significant hydrocarbons usually is a direct result of the over-circulation of the amine. And when you're over-circulating the amine, you are spending more money on just that circulation. Even though you're meeting the spec, you are spending more money circulating, and as such, there's costs associated with that. Again, now you're having the high hydrocarbons coming over to the reaction furnace. With the high hydrocarbons, what ends up happening is you end up producing more COS, CS2. These need to be hydrolyzed back. to H2S to participate in the Claus reaction, and as such, your overall recovery efficiency might be affected. So a couple of areas to do with the circulation rate. So yes, to identify costs associated. So circulation rate, definitely there's the cost associated with that high circulation rate, and there's costs associated with the reduction in SRU performance due to that. So definitely, when we notice high hydrocarbon content, we recommend to our clients that we should do an optimization of their amine unit and verify what is that circulation rate necessary in order to meet their target specifications. Okay, we have a question here. If available, document explains process description of SRU, can you provide it? Definitely we can. We have, I would definitely suggest and recommend that you check out our YouTube page. Our previous webinars were more on a generalized sense of the SRU, explaining the processes and different pieces of equipment. And that would be the best resource in order to get that. If you need any more information, feel free to email me directly and I can provide that to you. We have another question that has come in by email. For the TGTU case where you show evaluation of reduced fuel gas consumption due to improvement of upstream efficiency, was this a simulated case or an actual demonstrated case? If simulated, how did you specify the quantity of fuel gas required? So yes, as we mentioned, tried to mention that it is a simulated case, the reduced fuel gas consumption in the TGTU, that is simulated. How do we specify the quantity of fuel gas required? Now, for the TGTU, for a Scott unit, what you do need to ensure is that you have sufficient hydrogen in order to participate with the hydrogenation reactions of those compounds back to H2S. The target that we used in the simulation is 2%. And normally for the TGTU, you need to we recommend having an analyzer at the top of your quench tower to verify that you do have 2% hydrogen remaining at the outlet of your Como bed. And so that is the set point that we used in order to figure out how much fuel gas was necessary for the cases. I'm really glad that some people found this webinar very useful. We strive ourselves at SRE to provide very valuable webinars and provide very valuable information to our clients and to customers worldwide. If there's any questions that you may have, any comments that you may have in how can we better improve our presentations, or if there are any specific topics that you'd like us to present on, please feel free to email me, send me a message on WhatsApp on those topics, and we can definitely be more of service to you. Like I said previously, we're always here to answer your questions. Should you have any concerns at all with your SRU, we will definitely try our best to answer them. And what's great about SRE and what I really like is that because we've been servicing SRUs and different clients, we also have a breadth of relationships with vendors, catalyst providers, with equipment manufacturers, with analyzer providers. And so if we don't have the answer directly, we normally have a resource available at hand who we can ask on your behalf. Thank everybody for your attendance. Thank you all for your attention. We appreciate that you've taken the time to be with us today on this webinar presentation. Have yourselves a great day.